In this video, I'll give introduction to stack data structure and some of its applications, where it is used and all. Then I'll be discussing abstract data type of stack ADT. Stack is a data structure which works on discipline last in first out. Actually, stack is a collection of elements, set of values, collection of elements. And those collection of elements, they are inserted and deleted by following this discipline. So if you are inserting the elements, then when you want to delete, which one can be deleted? Only the last one that was inserted, that can be deleted first. So this type of mechanism, we use it in our daily life at many places. See, whatever we do manually, we want to automate that one, that is computerize that one. So we write the procedures or the programs for those things. So we want our computers to do that. If we are using a stack in some application, then in our program also stack will be used there. Let us see few examples where stack is used in our daily life. So one example, if suppose there is a dead end lane, and in this lane cars are parked. Suppose there is a first car. This is a red color car. This is black color car. This is white color car. This is a dead end lane and 3 cars are parked here. So it means they are brought inside this lane from this direction. Then if I want to take out these cars, from which direction they should go out? This side is closed, so they have to go out from the same direction. So this side of the lane they can go out. So which car was inserted last? White car. Which car will go out first? White car. So that's how last in will go out first. So last in first out. In short, we call it as LIFO. So this is one example. Now let us take one more example. There is a can of balls. 3 balls are there. That is first red color, then green, and then blue. Now, from which direction I have inserted these balls in this can? This direction. This is the opening. This is closed. Bottom is closed. Then if I have to take out balls, from this direction only they will come out. So which was the last ball inserted in this can? Blue ball. Then which will go out first? Blue ball will go out. If you look into the can, which is the first ball? Blue color ball. It's not red. Red I can't see. I can see blue on the top. So on the whatever is there on the top, that is first now. Even if you look into this lane, then which car you will find first? White color car. So that white car is first. So the recently inserted one becomes the first. So first for in what sense? The first one to come out. First one to come out. So this can of balls is also a stack. Even we can take the example of a stack of plates or a stack of papers, stack of grain bags. Grain bags are kept one above another. In the warehouses, stocking is done, so the products are kept one above another. So it is like a stack. So we cannot take out any product from the middle or from the bottom. We have to take out the products from the top. I'll give you one more example. Next example of stack. See, this is a railway track, that is tracks for a train track, rails track. Then this is one more track. This is an extended track. This is called as shunting yard. Now let me show you what is the use of this one. Suppose this is a train. This is an engine, and behind that all cabins are there. This is engine. The point is the engine. So this is a train. It's coming in this direction. So it is facing in that direction. So it can go in that direction. If I take it on this track, then what entered first? Engine entered first. And the last cabin, suppose that the last cabin, that was inserted at last. Now when I take out from this one, so who is coming out first? That last cabin. Then when the engine will come out? At the last. So who will come out first? The last cabin that was inserted will come out first. Now watch this. I'll take it out in this direction. Now you can see that the direction of train has changed. It was going in this direction, so it has changed the direction. So by sending a train on this track and bringing it out from the track, it has changed the direction. So I can say that. So this we can call it as a stack. So if anything is inserted in the stack and we take out again, we can reverse that thing. So you can see that a train is reversed by using this type of track. So at junctions, at railway junctions, this type of tracks are available to change the direction of a train. So this is one more application of stack. Now one more, a general idea I'll give you. See, we have seen recursions. Recursions are the functions which call themselves. So their behavior is like loop, but they internally uses a stack. We have already studied about this one. So recursion uses stack. Can we convert a recursive function or recursive procedure as a iterative procedure? That is a procedure using loop. So from recursion, if we want to convert into iteration, yes, we can. So even a iteration can be converted into recursion. It is known that every recursion can be converted into iteration. But when you convert a recursion into iteration, sometimes we have to use a stack in iteration. Recursion uses stack, we know well. That is a system stack. We call it as a system stack. That is automatic. Programmer doesn't have to do anything. Compiler or the runtime system will take care of it. So we don't have to worry about it. But when we are converting into iteration, then we have to provide a stack. That will be called as a programmer's stack. So programmer should create a stack and implement the stack in the program. So we have to use a stack in our program. So sometimes when the recursions are converted into iteration, we have to use stack also. Not every recursion. Some recursions are directly converted into iteration. Some recursions we require a stack. So I will discuss this as a separate topic. I will take some examples and show you where the stack is required, where the stack is not required. So we will discuss this as a separate topic. But a general idea I gave you that if you have a known procedure in recursion and you want to convert into iteration, maybe you require a stack. And vice versa. If you have an iterative procedure and you are using a stack, means it can be done better using recursion. So that's all about introduction to stack. Now let us see ADT of stack. That is abstract data type of stack. So abstract data type will contain data representation and the operations on the stack. Let us look at ADT. Let us look at ADT of stack. ADT just gives the definition of a stack in terms of data representation and the operations. So let us see what is there in ADT. Data that is required is we need space for storing the elements. So as I said, a stack is a collection of elements. So we need space for storing those collection of elements. The next thing is we need a top pointer that is pointing on the topmost element in the stack, because the important one is the topmost element, which one was recently inserted. So top is a pointer pointing on the topmost element. Then these are the operations in the stack. Push means inserting a value, pop means deleting a value, peek means looking at a value. So let us see all the operations. I have taken an example here. Suppose this is a stack and this is the topmost value what I have inserted, and these are the values already present. So the first value that I have inserted was 10, then 16, then 20, then 25. So recently inserted one is 25, so top is pointing here. Now what does it mean by push? Inserting a new value. Suppose I want to insert 30. So insert it from the top. So as we know that always insertion and deletion is done from top inside the stack. That is from same end. So insert 30 here. So now which is the topmost element? This is the new topmost element. So let the top point here on position 4. So this is how we can push, inserting a value. Push means just inserting one value, right? Not all values. So if you want more than one value, call push more than one times. The next pop. Pop means deleting a value, taking out a value from the stack. So if we take out a value, topmost value will go, and next topmost value is this one again. So top will point on presently, whichever is topmost value, it will point on that one. Then peek means knowing a value at a particular index. So which is the first value inside the stack? 25. So first means not based on insertion, the based on deletion. So if this is a stack like a can, so if I look into the can, the topmost that I find is 25. So first value is 25, second value is 20, third value is 16, fourth value is 10. So I want to know which is the third value. So I should get the answer 16 from the top. So peek means looking at a value at a given position. It's not deleting, just knowing what is there. Suppose I want to know what is there at the third place. I got 16. Yes, I want to delete 16. So take out three values. So you get 25, then 20, then 16. Then you can take out 16. Like suppose the boxes are kept one above another. You want the third box from top. Then you have to take out topmost box, the next box. Then only you can take out that box. If you simply pull that box out, other boxes will fall down. So that's what we are imagining. We are having same type of data structure. So we are imagining that these elements are also arranged similarly. So to take out 16, I should delete or pop out 25, then 20, then 16. So pop is for deletion. Then next is stack top. This is not for deleting, just for knowing what is the topmost value in the stack. So right now the topmost value is 25. Just knowing the topmost value. Then is empty and is full, knowing whether the stack is empty or the stack is full. So right now stack is neither empty nor full. One more place is there. If I fill this place, then the size of the stack is 5, so it will be filled. So stack will be filled. Or if I delete all these values, then stack will be empty. So this is ADT I have explained you. That is what is the meaning of all these I have explained you. We have not seen the implementation. Now coming to implementation, how we can implement a stack? Let us recall once again. Stack is a collection of elements which follows discipline LIFO. So where do you store collection of elements? Array or linked list? Yes, these are the two physical data structures that we know. So we use these data structure for implementing a stack. We can implement a stack using array, or we can implement a stack using linked list. This is what we have to learn. So first we will see how to implement a stack using array. So when implementing a stack, we will implement all these operations. So that's all about introduction to stack and ADT. In the next video, we'll see implementation of stack using array.